Humans and bacteria have co-evolved over millions of years. As the cosmic dust from the formation of the universe cooled, bacteria shuffled strands of DNA, evolving from single-celled organisms into multicellular beings, and developed a more efficient and sophisticated symbiotic relationships. Humans are superorganisms, which means that several different types of organisms, human cells, bacteria, yeast, viruses, and parasites live in symbiosis on and within our pliable skin covering. We are essentially bacteria-powered organism, Bacterosapiens. The human body comprises 10 trillion human cells and 90 trillion bacterial cells. The human gut microbiome has a community of microorganisms that occupy our digestive tract and contain more than 1,000 types of bacteria. Consuming foods containing beneficial bacteria can help support the bacteria in our bodies. Fermented foods are rich sources of probiotics and beneficial bacteria. Fermentation of food helps with nutrient absorption, vitamin synthesis, breaking down proteins, alkalizing pH, restores homeostasis, boosting immunity, and producing immunoglobulins. Fermentation not only provides superior nutrition, it also acts as nature's fridge, allowing us to preserve food through long, cold winters. It also allows us to extract nutrition from foods that would otherwise be toxic, such as when the process destroys phytic acid in grains. Foods we eat have an impact not only on our physical well-being, but also on our mental and emotional well-being. Pregnant women fed nutrient-dense foods and ferments to nourish themselves from before procreation to pregnancy, all the way through nursing, thus ensuring healthier newborns, maximum milk production, and increased nutrient density in breast milk. As a fetus develops, its enteric system and brain are formed from the same tissue, connected by the vagus nerve, which acts as the core of the gut-brain axis. These two brains send and receive signals that control heart rate, sweating, speech, among other behaviors. Seemingly desperate conditions from food allergies to autism and irritable bowel syndrome to mental illness have been tied to the relationship between the neurological and gastrointestinal systems and the bacterial diversity in the gut. Understanding this relationship can drastically change our approach to resolving various neurological and gastrointestinal ailments. What are lactofermented foods? Lactofermented foods are foods that have been cultured by beneficial organisms in the right conditions. Beneficial organisms, yeast and bacteria usually, will feast on the sugars and starches and other components of the food. Natural pickling lactofermented foods have an active bacterial colony. Fermentation starts with the beneficial organisms called lactobacilli. These are bacteria that produce lactic acid as a byproduct of consuming the starches and sugars in food. To effectively preserve the food, it is important to have an anaerobic environment. Some are fermented under a brine, but needs salt, pickling mix, or starter culture to protect lactobacilli acids, as well as warmth environment between 24 and 28 degrees Celsius. Food, starches and sugars, and time, organisms will multiply to form a strong colony with the food protecting it from spoil and improving the nutrition. Organisms give off gases. Burping jars can help prevent an explosion from too much buildup pressure. Natural pickling brine for lactofermenting is 6 tablespoons of sea salt to half a gallon of filtered water, or 2.5% of sea salt is added to water. If you prefer a less salty flavor, you can reduce the salt and add a starter culture to ensure successful fermentation. Sea salt is most common but can be replaced or added with kombucha, kombucha SCOBY, or whey. This inhibits the growth of other organic matter so that the ever-present lactobacilli bacteria can achieve dominance and produce enough lactic acid to preserve the food for many months. Anaerobic environment is needed to ferment. Submerge, weighing down the ingredients. Rest covered using a breathable top or burp often at room temperature for 1 to 3 weeks. Transfer to refrigeration under 40 degrees Fahrenheit or 4 degrees Celsius. Under the right conditions, they respirate, giving off gases, proliferate, multiply, and give off beneficial acids. Specifically interesting is lactic acid, from where lactofermentation gets its name. Lactic acid transforms the food into something better, complex flavor, pleasing textures, and makes food more nutritious. They enhance digestibility of the vegetables, increase vitamin levels, produce enzymes, offer antibiotics and anti-carcinogenic substances. They support the growth of healthy flora in our intestines. The acids preserve and protect the food from spoiling. It is really a miraculous process. Sourdough breads, dairy, beans, meat, fish, eggs, and condiments can be lacto-fermented. Some vegetables should be fermented or cooked for optimal nutrition. Fermentation is far superior than cooking for neutralizing the harmful substances. Cabbage, broccoli, Brussels sprouts, and kale contain chemicals that block the production of thyroid hormone goitrogens. Beet greens, spinach, and chard contain oxalic acid that block calcium and iron absorption and irritates the mouth and intestinal tract. Raw potatoes contain a substance called hemagglutinins that disrupt the proper function of red blood cells. Cooking destroys or neutralizes these harmful substances, as does the fermentation process. Heating destroys enzymes, probiotics, and vitamin benefits. Fruits and veggies can be turned into delicious chutneys, relishes, pickles, tangy jams, and delicious beverages. Greens can be fermented through the process of sourdough, producing nutritious and highly digestible baked goods. Dairy is fermented into kefir and yogurt, as well as soft cheeses and hard cheeses. Not all cultured dairy still contains beneficial organisms. Raw, unpasteurized, means the milk was not heated excessively, nor was the fermentation completed at high temperatures. Either of those conditions kill off beneficial organisms or enzymes. Beans can be fermented too. Hummus, bean paste, miso, tempeh, soy products should not be eaten any other way because of the anti-nutrients soy contains. And meats can be fermented. Traditional fermented sausages, cured meats, pickled meats, including red meat and white meat, fish, and eggs. Finally, we can lacto-ferment foods as condiments, mayonnaise, guacamole, ketchup, mustard, and more. For most ferments, vessels used are jars, crocks, bowls, barrels, or buckets, preferably food grade. There are nice airlock jars on the market that prevent the fermented food from being exposed to organisms in the air, while allowing the gases to be produced by the beneficial organisms to be escaped. Weigh it down with a glass or a ceramic weight, or fill up a zip-top bag with water to seal the food off from the air while weighing it down. These setups should be checked for mold at the surface regularly. Usually, the mold will not trickle down further if other conditions are right. The basic idea is to keep the spoiling organisms in the outside air away from your ferment, and even if you use an airlock jar, there are no guarantees. The top of the ferment is still exposed to the air in the jar. Don't worry, just skim away any mold as it accumulates. If you use canning jars with metal bands, you'll need to burp the jars daily and sometimes even push the rising contents back down. Because the organisms give off gases, burping the jars can help prevent an explosion from too much build-up pressure. Don't be alarmed if the first time you do this and find that released air is a little stinky. This is normal. The airlock jars, which allow gases to be released continually instead of built up, is less smelly option. Some fermenting recipes, such as sourdough or dairy, will tell you to cover your jar with a cloth or towel so air can flow, either in or out or both. You can always follow the recipe's recommendation. Ingredient quality matters. Vegetables, fruit, herbs, and add-ins, choose organic whenever possible. They will not only be more healthy and contain more nutrition overall, but organic farming disallows the use of pesticides, which would otherwise interfere with the fermentation. Sea salt. Many lacto-fermentation recipes call for salt, and it is recommended to use unrefined sea salt. Do not use store-bought commercial iodized salt. Do not use standard table salt. It has added iodine and anti-caking agents. The iodine is antimicrobial and can prevent a good fermentation. Pure, uncontaminated water. Do not use contaminated well water or straight city water. This may contain chlorine, chloramine, or fluoride, among thousands of other contaminants. If your water is not clean or you don't filter it, purchasing spring water or filtered water. Mixing chlorinated water with cultures can affect the fermentation. Spacing. When fermenting, keep different cultures at least 5 feet apart from each other, preferably on another counter or in another room. If ferments are started with the same culture, even if they're different types, it's okay to keep them in close proximity. Storage. When fermentation is complete, the fermented food must be transferred to cold storage between 1 and 4 degrees Celsius or 33 to 39 degrees Fahrenheit. This slows the fermentation, protecting it from spoiling and keeping it static for the most part, though food continues to age and develop flavor. You can freeze lacto-fermented foods as well, but recognize that they won't age or continue to develop flavor in the freezer. Some organisms might die during freezing, and your food might develop freezer burn. However, it is a good second choice option. If you've used a special fermentation vessel, such as a jar with an airlock lid, you might consider transferring the fermented food into a more compact storage container. This not only saves valuable storage space, but frees up your special fermenting containers to make something else. Pasteurization was instituted in the 1920s to overcome illnesses that resulted when people drank the raw milk of animals with poor nutrition and raised in dirty conditions. Pasteurization destroys enzymes and beneficial bacteria, diminishes vitamin content, completely destroys vitamin C, B12, and B6, denatures fragile milk proteins, and promotes pathogens. Ultra-pasteurized milk is even worse. That milk is violently heated from cold to boiling within 2 seconds, rendering the milk completely unable to be cultured, such as for making yogurt. You must use calcium chloride to help for curds with ultra-pasteurized milk. Overall, pasteurized milk is associated with allergies, increased tooth decay, colic in infants, growth problems in children, osteoporosis, arthritis, heart disease, and cancer. Homogenization is the commercial processing of breakdown larger butterfat molecules to prevent them from rising to the top. Homogenization is linked to heart disease. Raw whole milk is the overall best choice for making cultured dairy because it offers abundant healthy fat, probiotics, vitamins, minerals, and enzymes. Yet, not all raw whole milk is created equal. Some of it comes from less desirable breeds. When choosing raw whole milk, you have 2 choices. Raw whole milk from an old-fashioned breed of pastured animal, such as Jersey, Red Devon, or Brown Swiss cows, goats, or sheep. Raw whole milk from a modern breed of pastured animal, such as the commercial Holstein. The milk protein suffers a genetic mutation, making it unstable in our digestive tract. This mutation is linked to serious health issues such as autoimmune disease, heart disease, type 1 diabetes, autism, and schizophrenia. Also, the modern Holstein milk contains more water and less nutrition ounce for ounce. Additionally, when choosing grass-fed dairy from cows, goats, or sheep, look for evidence of clean milking conditions such as clean containers, clean milking area, and healthy-looking animals. The animals should eat rapidly growing green grasses during the spring, summer, and fall, and stored dry hay in the winter. Some grain offered during milking time is allowable. Animals should not be fed soy meal, cottonseed meal, or other commercial feeds, nor bakery waste or chicken manure, as is often the case in commercial dairies. Sadly, animals in conventional dairies are grown in confinement and never eat grass. If the animals are not healthy, the milk from them cannot possibly be healthy. Cultured dairy foods undergo a thickening, curdling, or coagulation. It is when the milk protein and or fats clump together. This happens on the order of a slight thickening, such as kefir or yogurt or sour cream, or it is a stronger separation into curds and whey, such as cheddar cheese. There are two means of coagulation. Acid, proliferating organisms, produces acids that feast on milk protein, casein, and sugar, lactose, and over the time, these acids curdle the milk. Rennet. We can add rennet, a substance containing enzyme, to the milk. This acts quickly, separating the milk into curds, solid, and whey, the liquid. Whether you end up with sour cream, cheddar cheese, kefir, or cottage cheese, it depends on a combination of how the dairy is cultured and curdled. Other factors come into play, such as how long the culturing takes place, at what temperature, and whether pressure is applied, such as a cheese press. Dairy kefir is a yogurt-like cultured dairy product made from milk and the mother culture kefir grains. It's fresh, tart, and effervescent with a large variety of beneficial bacteria and yeast. These microorganisms are able to colonize the digestive tract, boosting gut health. Dairy kefir is made by introducing a dairy kefir grain, the culture, into any kind of milk, even non-dairy milk like coconut milk. The grain, a symbiotic colony of bacteria and yeast, feasts on the lactose, the milk sugar, and as a result of this process creates a thickened milk with the consistency of thin drinkable yogurt. Kefir is low in lactose, while rich with beneficial bacteria and yeast, and high levels of vitamins, minerals, and enzymes. The kefir itself can be drunk plain or used for cheese, smoothies, drinks, salad dressings, ice cream, popsicles, and more. Kefir is a natural antibiotic and does not feed yeast. It may be eaten by those who are lactose intolerant because the beneficial microorganisms, lactase enzyme, consumes most of the lactose. It contains up to 5 times more probiotic organisms than yogurt, rich with vitamins, minerals, and enzymes. Kefir grains are a rubbery, somewhat translucent, whitish yellow clump and shaped like a cauliflower. These grains contain bacteria and yeast growing together along with casein, milk proteins, and lactose, the milk sugar. They can be very small or quite large. You only need 1 to 2 tablespoons of kefir grains to culture a quart of milk. Brewing dairy kefir. Put 1 quart of raw milk into a wide-mouthed quart-sized jar. This may be warm from the milking or cold from the refrigerator. Add the hydrated dairy kefir grains and stir briefly and gently with a wooden spoon. Use 1 to 2 tablespoons of grains per quart of milk. Cover with a cloth napkin and secure with a rubber band. Leave at room temperature away from other cultures. Let culture until you are happy with how thick and sour it is. It will get more thick and more sour over time. Eventually, its thickening will turn into curds and whey. You might see threads of yellow liquid surrounding the kefir curds. This is the beginning of the separation. In general, 18 hours to 2 days, depending on your preferred thickness, taste, and temperature of the room. Gentle stirring helps to achieve a smooth consistency, especially when trying to achieve a thick consistency. When you're happy with the kefir taste and thickness, retrieve the grains with a wooden spoon, transfer the kefir grains to a new batch of milk, or store in the refrigerator until needed. Water kefir. Similar to kombucha, water kefir is a fermented beverage. It is dairy-free, rich with probiotics to aid a healthy digestive system. Quick to brew and a beneficial alternative to soda with endless flavor possibilities. Water kefir grains are added to a sugar watery solution. The microorganisms eat the sugar, and over 2 to 3 days of fermentation, transform the sugar water into a mild, fizzy drink rich in lactic acid. By the end, very little sugar is left. It is usually mild and somewhat plain tasting, but it can be flavored. It can also be fermented a second time with fruits or other flavors to create a unique fruity flavored beverage. The second ferment is what makes water kefir fizzy. Flavor ideas. half a cup of raisins plus 1.5 tablespoons of vanilla extract, half a cup of chopped pitted dates plus 1.5 tablespoons of vanilla extract, half a cup of dried fig pieces plus 1.5 tablespoons of vanilla extract, 2 to 4 tablespoons of grated fresh ginger plus a quarter cup of fresh lemon juice and a splash of vanilla extract, several dried peach slices, a splash of vanilla extract or other dried fruit.